Welcome to Groundwork, a new podcast from McClanahan Corporation to talk about key material processing topics, from agricultural to mining to material recycling. We'll discuss the best ways to process the raw material that power the world, because if it's not grown, it's mined. I'm one of your hosts today, and my name is Renee Schrift, and I'm with McClanahan Corporation. And I've been with McClanahan for about 23 years. I grew up on a dairy farm in central Pennsylvania. My husband dairy farms today. We live in Pennsylvania, reside in Pennsylvania. My title today is director or product line director for the agricultural systems that covers everything that we sell agriculture into the agricultural markets. We mainly focus on dairy, but we've also focused in some other livestocks as well. We have a fantastic team. One of our engineers is joining us here today, who is the director of our agricultural group, and I'll let Mark introduce himself.
Hi there, Mark Sell, Director of Engineering for the Agricultural Group. As Renee said, I'm in my 19th year with the company. And like she said, we do a lot with the dairy industry, and the bulk of my time here has been spent dealing with layouts and just applying our systems. So not so much the nuts and the bolts in the shop, but rather how the systems are used in the field. And I'm local to Central Pennsylvania as well, so Penn State grad. And glad to have you with us.
Most of our team is Penn State graduates. There's a couple outliers, but I would say that most of our team has graduated from Penn State, whether it was an ag business, engineering, or agricultural degree. So I think that adds to everything that we offer and what we do. Our topic today is to cover manure management and what McClanahan offers for manure management, all the processes, systems that we offer, and just kind of diving into that topic. And I like to also look at it as far as not so much manure management, but even the cow management side of things. Our roots and the basis of what we do has always been centered around the cow and cow comfort. Would you agree, Mark?
Yeah. It's always been told to me, sand is the gold standard, and that's kind of where we come in for bedding material. But yeah, it goes beyond just the bedding. It's the whole process around it.
Yep, it's the whole process. So today, we still focus on all of these great things that go along with our product line and what it offers the dairy industry today, as far as separating sand, getting high recovery, and then being able to reuse that sand back under the cow. We also have manure dryers that also address bedding concerns and just trying to improve that quality of the bedding that's going back under the cow, whether a dairyman is choosing to bed on sand or bed on manure solids or manure solids post digestion, whatever it might be. We have those systems or a system to help enhance that product and make it better or maybe more closely equivalent to sand. I don't think anything's going to take away from what sand delivers to the dairy industry today and what it does for the cows, the comfort, the traction, and all of the comfort that it provides. But we do try to always look forward and try to stay on more of the high road as far as what we're offering the dairy industry that's the best for the dairy industry. So when we're talking about sand and we're talking about manure bedding, whatever it might be, I think the one thing that we always have to come back to when we're talking to a dairy producer who wants to look at incorporating sand separation on their dairy is just the whole entire manure management piece. And that's our main topic for today. So from an engineering perspective, we need the engineers to help us to go onto these sites and actually look at the big picture. So we're not just looking at, this manure comes here to this tank and we need to separate this sand, but we got to look at the big picture and conveyance. How do we get the manure to the system? Once it's through a system that's reclaiming sand or pressing solids, then what? Then where does it go? Just being completely mindful and respectful of that entire process. So I don't know, Mark, if you have anything that you kind of want to add in there from the engineering perspective, but from the sales perspective, that's kind of like where I sit and see what we do.
Yeah, I know when I talk to a lot of, especially, local people and whatnot, the question's asked, what do you do? And I tell them, we work with manure equipment, and they say, you make spreaders. And Well, it's more than that. Spreaders, traditionally, that's a vital part of any dairy farm. You need to spread the fertilizer and everything. But where we get involved is a lot more to the manure system than just getting rid of it. We're trying to process it, obviously sand separation, but as you noted, we've got, solid separation and dryers. We'll talk a little bit about that. And it's really just utilizing all of the manure to its fullest value.
And on these dairies, it's manure 24/7. So no matter if you're, 100 cows or you're up to 12,000 cows on a dairy site, I mean, it's all relative to whatever you have and what you need to process and how you need to process the manure and the size and scale, and how you're going to manage it long term.
So we can, I don't know if you want to start with conveyance. We can run through that a little bit.
Conveyance is a great place to start. Yeah. So if you want to just kind of talk a little bit more about conveyance from the sales perspective, and when we look at it, we're saying, okay, what's the easiest and the quickest way to get this manure from these alleys to a centralized reception pit? But there's lots of ways to go about it. So maybe Mark, you can kind of talk a little bit more about that.
Yeah, obviously to handle any of the processing of manure, I mean, even if you are daily haul and spreading the manure, we need a way to get the manure out of the barns. And so that's usually where we start. And there's a lot involved with that. It's not, it can be as simple as a tire scrape just to get the manure out of the barn with a skid loader or whatnot, or alley scrapers. If you have to go any distance to get it into a collection pit, that's where horizontal augers and things come into play. And then depending what your infrastructure is at the dairy, whether you have water available or not, then we start looking at flume systems and things. So there's a lot to consider when you talk conveyance. It's more than, it is simple in theory. It's point A to point B, but there's a lot involved in making that decision.
I just remember back in the day when I first started, horizontal manure augers were just taking off. And we did a lot of engineering around that. And then looking at, it was a quick, easy way for a dairy that was 500 cows or maybe up to 1,000 cows who was using a skid steer or a tractor with a tire, scraper blade, and they were scraping that manure across the barn. And instead of turning it and chasing it or pushing it and taking all this time to move it down then another 100-foot of alleyway to a reception pit, then we started really talking about augers and the efficiency of that. So that's kind of like where we really started with conveyance and fluming, but really the augers took off back in, I think, 2000, 2001. We did a lot of work in New York and Wisconsin with those. And then today, looking at it, a lot of those are still in and running. And then those dairies have expanded and they've been able to add on to those augers. And maybe there's another barn that's connected. And so we can connect these things kind of like Legos in a way, just kind of keep building them out. And with the technology that we have and the information that we have today on all the stuff that you guys do and provide as far as like lengths of auger, horsepower, things like that, and the limitations behind that, that's allowed us to grow and lengthen what we do. And it's not just a 100-footer today. It could be possibly a 200-footer with one drive going across a barn and, a half or whatever it might be. So those have allowed us to work with the manure more efficiently, the dairy more efficiently, instead of turning the manure and chasing it. They've been able to have the manure dumped right into an auger, and it's taking it away basically in real time to a reception pit and getting and putting it there for further processing, which is really it was really exciting to hear dairy producers talk about the fact that sometimes these augers are a real time saver for them, because otherwise chasing the manure and turning the manure and trying to get that alley clean, it could add another hour or two to their day, just even in a skid steer. So the more that we can get people, in the barn, efficiently get the manure off the alley as quick as possible, so those cows can come back and eat and then lie down and do what they're supposed to be doing, and that the dairy producer wants them to be doing, the behaviors, the better. So getting the manure in the alley clean and efficiently moving that material to a pit, that's always been impressive to me. And we have started a lot of conversations with that over the years, and so those augers play a big part. Obviously we always want to be efficient. So if it comes to the point where the augers just are not going to play well with a really wide cross ventilated freestyle barn or two in a row, and we just can't really physically make it work. I think that's where that flume really comes into play, like you're talking about.
Mm-hmm. Yeah, just a little bit more on the engineering side of the augers. Like I said, it means a conveyance, and it's to get the manure from the barn. We got to clean the barn out first, but we can get from the barn to a reception tank somewhere. We can go up to 216 foot with our augers. They come in 12-foot increments, so we have a bearing every 12 feet. So we can span, troughs or whatnot. If we need to discharge to a pit or cross over another auger, we can even turn it with multiple augers. So we can go 216 feet with one auger. And then if we have further to go, we can piggyback them together. We can sidestep whatever. We can go almost infinitely long. You talk efficiency. You'll notice at McClanahan we use a lot of augers. Augers perform well with sand. We design them such that we don't have close tolerances, so we don't have a lot of the wear, or at least minimize the wear that we have. One drawback that I will say with the horizontal auger, we run a 16-inch by 16-inch trough, a concrete trough, and then the auger is 12-inch diameter in that trough. So it's not going to operate 100% efficient, but that's one drawback. But they do operate efficient for what we are doing. When you look at conveying sand, the downtime, you got to factor that in too. And so maybe the augers run at 1 foot per second is the design speed that they operate at. And, the manure probably doesn't move at that full speed because it's not 100% efficient. But when you factor in the lack of downtime because the augers do perform well, it is an efficient design. Depending on the length, we put 5, 10, 15, and up to 20 horsepower drives on these augers. They're typically a belt drive reducer at the end. We have done some other custom drives, direct drive and things too, if we need to worry about clearances within the barn, or if we're like piggybacking or something like that, we need a little lower profile, we can do that. So yeah. Onto the flume then, like you said, the augers are great. I think the flume, the nice thing is if you have either a full alley flush or even just scrape into a flume pipes are nice because you can allow for some bends in the line. Augers are pretty much limited to straight runs. If grades work for us, we can overlap them and make a minor directional change. But with the flume pipe, you can, again, within reason, you don't want to be turning 90 degrees, but you can make some minor adjustments, dogleg between two barns or something like that if you need to. Flumes are critical. They have to be designed on the proper slope, and that slope needs to be maintained throughout. But they are a really good fit for a lot of systems, and we can help with the design of that too.
Yeah. Going back to the augers, the other thing that works out really well is just the alley scraper. I forgot to mention that earlier. Mm-hmm. So, in addition to the tire scrape and the tractor or a mechanical piece of equipment running through the barn, moving that manure off the alley, we also can, work a lot with alley scrapers. They're a great tool to move that manure off that alley more frequently, whether, it's running with cows in the barn or not. Usually they are. But that's always been interesting and kind of unique to what we do too, because the auger can turn on and off as that blade with that manure, pushing that manure to that trough or that auger concrete trough. Then the auger would turn on and it would move that manure as that manure was just dropping like slowly off the alley into the trough, and then it just moves it and moves it. I always love watching that. Actually, I know that's kind of weird, but whenever the augers turn on and then the manure is just slowly moved in and the manure is just taken away flight by flight by flight, and it just moves it across that channel to that reception pit. So very easy, quiet type of system. I think that's very efficient as well, because then you're not putting that, if you're interested in trying to keep more people out of the barn and taking care of more of your freestall facilities and removing that human aspect of it, of cleaning, then that's also an option. And so it's always intrigued me that those augers just work so well, whether you're scraping into them or you're using an alley scraper, and integrating those two things together. And also just the control side of it, with augers, like they can be jogged on and off in cold winter temperature time frames seasonally, and then the automatic timers to shut them off. So if you're going to scrape and it takes you 20 minutes, then you can set that thing up to just turn off then after 20 minutes. So it's not running all the time 24/7 like a flume would. So smaller facilities or more controlled scrapings, I think that works really well. Now getting to the flume, the flumes, it just seems like, we see flumes probably even run a little bit more efficiently whenever those pumps can run 24/7 and we're just constantly moving water through the flume. Would you say that, I guess there's lots of different types of ways to flume. We see the tank flush, and then that's a flume pipe technically, where we're flushing that manure to a system. And that's more, I call an event flush. I don't know if I made that up or what, but it's more of an event to me because it's all at once. And then you're processing right there. Everything turns on and you're quickly processing and you're waiting for the next flush or the next flush event. With fluming, and just I think 24/7 fluming, that's where we're hydraulically moving material 24/7, or it's timed with like a scraping, and you want to have that water running through that pipe before you scrape. So
yeah, we can either do 4-eye flush, which is, as you noted, pop-up valves in a tank, and that flushes the alleys of the barn. That replaces the alley scrapers. And then it's collected in a flume pipe, and it's all gravity from there. Or the other option with the flume pipe is the pipe itself kind of replaces the horizontal auger. So you still have that scraping within the barn, but the flume pipe has water in it, and that's your conveyance method. So.
Yeah. And I think all of these things have to play well with how like going back to this overall manure management topic, like they all have, all these conveyance methods have to play well. And there's not very few farms where there's blended manure conveyance. I think that we see more people even actually gravitating, if they can, gravitating to back trucking, and getting that and using a back truck as a tool to get the manure off the alley when the cows are in the parlor, holding area, et cetera. So they're using the back truck to clean and then get that manure quickly off those alleys and then deposit it either into a flume or into a tank. But I think your entire layout of your facility, whether you're talking older facilities or new facilities, that's really going to come back to dictating how you're going to get that manure off that alley and plan to get it strategically, logistically, efficiently to a reception pit or a spot where we can process it and further process it.
So Charlie Brown says there's two things people sit and watch. One is a crackling fire and one is a running stream. We're going to add scraped manure to that list.
I think we should. I mean,
we can.
Honestly, like the anticipation of standing at a barn and listening to the pipes and hearing the air movement because the flush is about to hit the alley. I mean, there's just something about that with me. I don't know what it is, but I do enjoy that. I also enjoy watching manure being scraped and just even watching people manage that, get that off the alley and how they're going to back up and what they're going to do and what angle they're going to take. I mean, that's just interesting to me. It's kind of, I don't know, I guess call me really weird. I do not know.
It's kind of like shoveling snow, but manure's there all the time.
It's always happening. It's an amazing product. It's so versatile, like we're using it for bedding, nutrients on the ground, all these things, making gas. So I think that, I don't know, it's just interesting to watch, and high volumes of it are even more fun. But anyway, but I think the bottom line is that, kind of got a little excited about augers right out of the gate. About 20 some plus years ago. Augers are a great tool. And I really, we've had a lot of dairymen have had a lot of success with those, just efficiently moving manure out of a barn. It saves a lot of time, especially I think on some of these even smaller dairies, when you get to the point where you're not going to have people available to just, that's all they do. And they're managing 5 or 6 other aspects of that farm. And so they need to get that manure scraped and then they need to go on to the next thing. So I think augers have really saved a lot of time there. Flumes as well. Flumes, I think the key thing there is design. It comes down to knowing what you're fluming and where it needs to go. And then look at all the I shouldn't say little nitty gritties, but all the important things like flow, slope, sand, the type of sand, how much that weighs, calculating all those things that you as engineers do. to make sure that's designed really well, because the last thing you want is a plugged flume. The last thing you want is a flume that doesn't work. The last thing you want to do is say, hey, the flume works, but it has to run another hour in hopes that it erodes whatever settles in there to get it to the process tank or the storage. So you don't want to have unknowns and guesses and maybes. I think with flumes, you want that designed correctly right out of the gate. And we've seen a lot of success too with, and I've enjoyed watching these too, as far as like the tower flushes, those big event flushes, they work really well. They really clean the alleys well. But again, I think that comes down to that whole looking at the facility as a whole and your entire manure management as a whole. And, is that going to work on this site? Do I have the elevations to work with? Do I have the right slopes to work with to make that efficient? And there's really little to no issues that result in designing something like that and working with it. So we can move on a little bit more, but I know the one thing that we didn't really cover is pumps. I see a lot of guys before they even put a system in, they use piston pumps or augers to load out into a spreader, and that can work too, as far as just the next step, as far as getting the manure out of the barn. What's the next step? If you're on sand, obviously, you might be exploring, or dairies have explored, obviously, looking at sand separation. If you're on sand, do I want that sand going to my storage? Do I want to have to haul it out again? Do I want to have to pump it out again? Or do I, put, a sand separation system in to process and remove as much as I can? So then I'm just going to my storage with more of a liquid manure product. The same thing with a flume, but the next step into that, it just takes a lot more planning and discussion on where you're going and where you're heading with your manure management system, or your manure management plan, I should say, on your dairy.
Yeah, I think that's discussion there. Flume versus scrape is what it boils down to. Augers would be scrape, flumes, regardless of what method of flume, whether it's a flume pipe running or the full alley flush. At that point, it's dilute. Yep. And so then that's kind of a good segue into the next topic of manure treatment and how we handle it downstream. Mm-hmm.
Yeah. So like I was saying, like if the dairy's bedding on sand, depending on what type of sand, or there's the whole sand discussion, which that's probably segue number 2 or podcast number 2 when we talk about sand types, because that's a whole another beast of a topic. But really, when dairies are bedding on sand, they have the option of putting it into the storage or a tank, or maybe they are, more of like I shouldn't say daily haul, but maybe they haul out once a week. They really don't have like a lot of storage available. Maybe they maintain their parlor storage and they utilize that during certain times of the year, but then they just haul out these short-term, smaller manure storages, or they have like just a concrete tank that they're pushing into, and they hope that some of that sand settles in there, and then they can more easily manage it and load it out with a concrete basin, because then you can get down in there and you can move it around and you can put it into spreaders or whatever you're going to use to land apply it. But when we're looking at sand separation, what are some of the key things that we need to be talking about as far as setting up a system like that, as far as setting up a sand separation system? Now that we got the manure out of the barn, if we want to set up a sand separation system, what are some of those key things in your mind from an engineering perspective that you want to hear, what information do you want in order to help better plan a system like that?
Okay. Yeah. Going back to the conveyance a little bit, like I said, we've got scraped manure or dilute manure. And I think as an engineer, I like the idea of scraped manure, because we scrape the manure out of the barns, we deliver it via an auger, and we get it into a reception tank to our process system. At that point, it's still the same manure that was in the barn. And so whatever dilution and things like that we need to do for separation, we've got full control of the process. Dilute manure, I feel like producers probably like that better, because they can scrape manure out of the barn, get it into the flume pipe, and it's flushed downstream, and it's out of their way. If it's delivered to the building, to our separation process in a dilute manner, then we approach it a little bit differently. And just some other aspects to take into account there. It's already dilute when it arrives, and so we kind of get what we get at that point, but we can still tailor it and make things work. We've got good systems for both processes. So just the quick and dirty of sand separation, you need to dilute the manure and allow the sand to settle out. And then, and so that's where I come back with this, the scrape system, we can control, we've got full control of how much dilution comes in a dilute system. It's already coming in dilute. Usually we add a little bit more once it's in our system. But we're starting with some kind of pre-dilution, which is good in a lot of ways. It can present some challenges too, but, so yeah, just walk through, again, we use a lot of augers in our systems. And so when we have that dilution, the idea is to have that dilution occur within the wash box of the sand separator, sand manure separator. I'll just start with our bread and butter machine there. The dilution starts there in the wash box. The sand settles. There's an auger in the bottom. It's submerged. Part of the auger is submerged, but it pulls that sand out of the wash box area. Up the dry deck, it can be dewatered there, and we do add a little bit of fresh water to help kind of final rinse, clean the sand, and then it's discharged to a pile. I'm really trimming that down for you here, but and something else to point out when I talk dilution water, all the water we use in our systems, almost all of the water we use in our systems is recycled water. So we aren't pumping a bunch of well water into the system. That would be in a scrape system. The dilute systems operate a lot the same, except we approach it a little bit differently. So the manure that is delivered to the wash box area of the sand separator is already kind of pre-separated. So it's more of a concentrated sand coming in, and then we just are further separating and cleaning from there.
Yep. So when we're working with dairies that are scraping the manure and it's coming in as like a thicker product or an undiluted manure product, we're not diluting it to move it. We're just mechanically moving it via augers, vac tank, scraping. Then that manure is treated just as a undiluted product. We're pumping or augering or whatever we're doing into a screw washer, and at that point, that's where the dilution takes place. So we want it's a little bit more controlled because we know we kind of know what we're getting. I mean, obviously there's seasonality changes with summer, winter, even dry cows, heifers, mix numbers. Adding on, putting more lactating cows on. So that manure consistency can change, and it can be a little wetter or a little drier at times. But it really, the bottom line is that the sand's incorporated into that manure, and we need to dilute it once we get it, or once it's delivered to a pit. We need to dilute it in order to separate the sand and let the sand just move away from the manure solids and drop out, settle, and then we can convey it, clean it, and then discharge it off the system for the dairies to reuse pretty quickly. I would say within a couple weeks, they're reusing it back under the cow. The high dilution systems, just to kind of summarize a little bit, just understand everything that you were putting out there is, you can have a controlled rate coming through, but it's a lot bigger volume. We're not talking about, so many gallons per cow. We're talking thousands of gallons coming in at a time. And so we have, let's say you have a flume running at a minimum of 2,000 gallons a minute. And then you also have the manure added to that flume water. So you have a lot of volume coming in all at one time, and you're diluting that manure as you're conveying it. So as you're diluting, sand's going to drop out pretty quickly. So the dynamics of the systems change at that point. And so you have to think about, okay, the dilution's happening with the conveyance, it's coming in, sand's going to start settling out immediately. So how do we work with it there and also end up with the same product, same equivalent product as a scrape dairy, same thing. Sand's discharged from a system, and then they can be reusing it. Now we talk a little bit about recovery rates. I think that's a time for probably a different podcast to talk and hone in on some of these recovery systems and what we're doing on recovery. But the bottom line is we like to see dairies, even just with this, setting up a system and designing it for their dairy. All the systems seem to be a little different. There's not one that's really the same or cookie cutter. Even if we have two identical dairies side by side and they put systems in, there's bound to be something different. They can say we mirror it, but it's not. There's always some kind of little nuance or something that we change, which is fine. And I think that goes along with the engineering and the expertise that we have. and the flexibility to make these systems work for each individual dairy for their manure management needs and also their employee management. Because you obviously, these are mechanical, they're not just going to run all the time by themselves. We want to try to minimize that interface with the system, but we also know that it still needs to be there, right? So once we get the sand out, and then what are the opportunities after you remove sand from a manure stream? Where do you see the opportunities?
Right. Once we've removed the sand, obviously we can dewater it and do what we need to do there, condition it. We can get it back under the cows and recycle it. The manure then at that point is essentially sand free. So we can either go to, historically, it's, a long-term storage, and you don't have to worry about sand settling in an earthen line type lagoon. I still recommend maybe a concrete lined, for an initial cell, but at any rate,
like a pre-cell,
right.
a preliminary cell, just as a buffer.
Yep. Just as a buffer, it's always a good idea. Even manure solids over time can settle, and you don't want to have to dig those out of a plastic lined or earthen lined lagoon. But yeah, in today's day and age, the digesters are the big item, and I feel like with our systems, we have a very good product to offer. I didn't talk a lot about it, but our systems, we talked about the sand separator and the sand settling out of the wash box. That's the very, very basic system. We do have, that would be, I'd say, phase one. We have second phase. We operate, we take all of that effluent manure and run it through a hydrocyclone, and any of the fine sand or whatnot that didn't settle in the first phase, we catch it there. And then the third phase is we typically will add just a small sand lane, just a little settling lane. It's not even sand that you're going to want to reuse under the cows, but just the dust and even coarser manure solids that aren't going to be digestible in things anyway, that would settle out and just give you more headache than they're worth. We settle that out on a sand lane, small settling cell, and then discard that. So once you've gone through those three phases, the manure stream is good. It's just manure. It's in a liquid form. You can pump it. Within our system, debris can be a problem, so we have some debris screening at the front side of our system. So at that point, the debris should be out, so you can still pump that manure however you need to. And like I said, we can go to a digester, and digesters are a good thing to design for whether you have one or not, because you've got an enclosed tank, and so if there's any sand, any debris, anything like that that's going to settle out over time, you're going to have major issues. And so we really want to address that stuff before it gets to that enclosed tank.
Yeah, I agree. I agree with you. I think about that all the time. Like, do you differentiate the fact that for just a regular commercial dairy, bedding on sand, 10 years ago, in between these two digester peaks of high interest, whether it was electrical based style systems or just putting them in for bedding and PR and getting permits, or today's world where, it's more about the renewable natural gas side of things. And so it just continues to move on, and it has stayed here. It's a state as far as conversation and development, and integrators have continued to move those systems forward. And I agree with you, like we get into these conversations all the time about can you bed on sand and still have a digester, or be feeding a digester with your manure stock? And the answer is yes. But we know that we've had to really dig in and improve what we're doing as far as overall recovery, because dairies aren't just going to always bed with a very specific sand type. They're going to bed with whatever is probably more local and affordable, and they can get readily, and it's readily available. That's the way it's always really been. When we talk about where they get their sand, where it's coming from, trucking sand from 100 miles away just doesn't seem efficient or logical at all. But you're going to have dairies that are going to, bed on all different types of sand. It's not just one type. Across the U.S., internationally, they're all different sands. Michigan alone has been a state where sand can vary so much from lake to lake. It's incredible how the sand types are different the whole way across that state. So we have worked with all different types of sand, but it makes us, I think, think about sand separation differently, obviously, with digesters today. And you're probably right, and really have something there by saying that maybe we should be designing, whether you have one or not, to do a really good job on the sand separation side of it.
Yeah, I know we have a recent customer started up, and they have a large circular concrete tank. It does not have a digester, but again, the tank's kind of limited in access, and they have access all the way around. If they had to, they could dig it out if they had, a lot of bypass or things. But, the point is we don't have to worry about that as much. Obviously it's a manure system, anything can happen, but yeah, he's designed for it now. If down the road, like you said, 10 years down the road, something like that, he wants to add it, he could. The system's already in and ready to go. And the nice thing for him is it's already tested out and fine-tuned at this point.
And proven.
And proven. Yeah. And then, as you noted, two sand types, that's one of the things I like about our systems. We are McClanahan. We know sand. Most of our equipment makes sand, or cleans up what's already in the earth. But with three phases, we can kind of tailor that. So if we do have a different grade of sand, a finer sand, we can kind of rely more on the second phase, the hydrocyclones of sand separation. Right. Or if it's a coarser sand, we can fine tune the front phase. And that's one of the advantages we have of multiple phases there. The net result is pretty much the same across the board, but it does depend a little bit on the farm and the sand types that we're using, and in the locality. Like you said, Michigan's different than, say California. I've not been on a lot of quarries to know the different sand seams out there, but there's a lot of difference that way. And like you said, even Michigan, maybe 20 miles apart, there could be totally different sand available.
Right.
So.
Yeah, I think you find that anywhere. We even just working with dairies in Pennsylvania. I mean, obviously the sand's going to be different here, whether it's a glass sand, a manufactured sand, or if it's a sand that's just more of a screened bank run sand, and it looks really good as far as the particle size distribution. And you think, okay, that we're going to be able to, with this thick manure and recycling the water and everything that we do to mitigate adding more water to the system, we try to separate the sand with the recycled water and do the best job we can. That's a big, that's a tall order. I mean, because we could make sand look pristine clean and separate out probably even more than just the sand if we use all clean water, but we don't. So we really try to reuse the water, make water from the manure stream coming in and the parlor waste, and make water within the system to dilute the sand or to wash the sand, either way. But we're trying to utilize recycled water. And when you're doing that, you're not working with just, anything less than 0.5% as far as water quality. We're working with things, we're working with water quality that's on the 4 to 5% range. And so it's thicker. It takes time, it takes equipment, and it takes putting all those things together in the right sequence to make it happen. And I think that we're still working on getting better at it. There's not one, like we said before, there's not one size system or one complete layout or process flow that matches every dairy that beds with sand and scrapes their manure or vacuums their manure to a pit and they want to process it. It's all going to be different. And it's really going to, we'll talk about sand at a later time and dig into that. But, we really just try to guide as far as like what we think is going to be a successful sand type to use, give them the best opportunity to separate out as much sand as possible from that manure stream. And then we have to dig in harder with the fine sand and try to get that out, because if it has a settling characteristic that it's going to settle and not cling to a manure fiber or be easily resuspended going through a digester. It's going to settle out and cause problems. And it's just going to pull other material down with it. So we have to do a good job. I agree with you. Above ground storages are just another vessel where you don't want to be getting in and cleaning something like that out, cleaning sand out of an above ground storage. Really don't even like to see people getting into storages and cleaning out sand, period. But it's there. It happens still today, obviously. But I think, did you want to share a little bit more about what we're how we go about some of those like designing a sand lane, or what we've incorporated into some of these systems to try to get that finer sand out, whether we're going to reuse it or not, whether it's reusable or not. We just need to get it out.
Right. Yeah. The smaller sand lane, the whole idea there is anything that's going to settle over time in a digester, you give it that chance to settle before it gets in a smaller volume. Obviously, we don't have the retention time in a small sand lane. You know, we're talking on the order of minutes versus, you know, days and weeks in a digester tank. But because it's a smaller volume, you know, we kind of give it that chance to settle out there before it gets into the tank. I was going to add too a little bit with recycled water. You mentioned, you know, obviously we can do it all with fresh water and have good results. We don't have that luxury at most sites, and
Nope.
and that's not always a bad thing. I feel like you know, having a couple % solids in the recycled water, I feel like gives a little bit better recovery even than fresh water would, because that you know, the mucus factor of the manure kind of helps cling to the solids and helps some of the solids that are kind of settling out with the sand. I feel like the, you know, a little bit of thicker recycled water helps keep those solids in suspension and allows the sand to still settle. So we get good sand recovery, but yet, you know, we're not forfeiting sand either. The only sand we might forfeit would be the dust and things that kind of cling to those manure fibers that are still somewhat in suspension, maybe not floating, but somewhere in between. And that's where the sand lane comes in. You know, once that effluent all makes it through our process and gets into the sand lane, then those fibers, it's a little bit slower velocity there yet, the throughput. And so some of those fibers are what we're targeting to settle out. And then we get the dust and things, the fine sand with that.
And really that dust or the organics that are in the sand, in a sand sample, or some of that sand that's moving or clinging to fibers, and really that kind of material you don't even really want in your stall anyway. I think from a cow comfort standpoint, you always want your stalls should always be loose. They shouldn't be packed and hard like concrete when you're bedding on sand. Even if you dig down a couple inches, you really shouldn't see a hard pan across there, and some of that finer material with clays and silts. When we reintroduce that back into the stall and it's a little damp, it's coming back in a little damp, and then the cows are adding manure back into the stall too, and temperature and compaction and things like that. So those types of materials pack, and I think they cause more harm than good, just even on the cow comfort side. So.
Yeah, and even if you have just a little bit of those fines going back into the stalls or even new sand, the cows, you know, till they dig around and kick sand out of the stalls, they're kicking the coarser grade out, and those fines kind of filter down through. And after a while, you're left with a lot of fines in the stall anyway, and you get that hard pan line like you mentioned.
Yeah, that packing. Yep. Exactly. So I think the bottom line is we really haven't come out with one solution when it comes to removing as much sand as possible prior to a digester. I think there's also, as the industry continues to work through this, there's also this trying to decide on what to really go after. Just a couple conversations, like even this week with dairy producers and integrators or developers. It's like, how far do you take it? Because you start to separate out volatiles when you start to try to look at taking out really fine, dusty sand and trying to isolate that out. How far do you take it? Because you're going to also be removing a lot of volatiles in those processes. And really, when you look at some of that sand, I don't think as an industry we've really assessed what sands will make it through a digester and what sands don't make it through a digester. Obviously, if you're cleaning out a digester, and then we've seen it from some of our customers, and it's raised some red flags for us as McClanahan to just try to figure out a better way. When you see the coarse sands making it to a digester, that's not good. That's not acceptable. But we don't know why that happened. There could be a lot of variables, but if it comes back to the process and the equipment and it's not doing its job, or something's not working there, then we need to try to address it and address it with either more technology or making adjustments to the system and how it's operating. But when we look at this really fine sand, or if it's even sand that could potentially settle or not, will it? So like I asked that question the other day, is how fine do we target? to take out. And I don't think we know as an industry. So I think there's more to come. You also deal with the digesters heating up, and hot soup is easier to stir than cold soup. So I always think that, I know that's a bad analogy when it comes to manure, but I think that as these digesters and these vessels are at a certain temperature, and your manure, as it's entering, it's probably not 100 degrees, but when it's coming out of the digester, it has reached a temperature for so long and duration in those digesters. So by heating that material up, what happens then? Like, do these sands and wannabes, like, or, maybe it's not sand, but it's like a silt or a really fine sand particles that are making it through. When do they start settling out? Do they? That's what we don't know.
Yeah. Yeah. Regardless, I would say that any of that fine stuff does settle out. When it does come time to clean it up, it's going to be a lot easier to agitate and pump that out rather than needing to dig it out, which would be the case with coarse sand.
Exactly. So then that comes back to that question, like, from a technology standpoint, do you really, really, really try to figure that out, and is it really necessary? We don't know yet, but we are putting technologies in place, and I think that's when you allude to the sand lane, whether you're flushing or scraping that manure to a pit, and you're doing the primary sand separation process to reclaim as much sand as you can to reuse back under your cows. Then you have this manure stream that could potentially still have another maybe 5 or 10% of sand still lingering in that water and clinging to those manure fibers that over time could settle. And that's why we look at putting in that next stage of that sand lane, and or a cyclone, maybe a cyclone before a sand lane, or maybe it's a cyclone after a solid liquid separator, or wherever it fits best in the system to take out more of the sand that could potentially settle.
Yep. Yeah, more to come on some of that other alternative separation methods. Like I said, we are McClanahan. We know sand. We've got a few things in the works. So, yeah, trying to adjust with the industry and just do a better job all the time. I've yet to do a layout that was the same as a previous job.
Right.
So we're always fine tuning and getting better at what we do.
Yeah.
So.
I do think it's interesting now that with these layouts and the overall, just going back to overall generalities of just designing systems and looking at them, I do think it's great that there's over the 25 years that we've had systems or plus. I'm not even sure exactly when 1997, 98, somewhere in there.
Something like that.
So we look back at some of these really basic systems and what we were doing with a sand screw, a sand separator, sand manure separator, inclined augers, and where it's come today and full circle, and the closed circuit systems that are designed and that we work with today in making recycled water with the rotary drums or slope screens or pumps. I think that it's interesting how we're not just talking about how manure comes in point A and it exits in point B. We are also talking about the overall management and that human part of it coming into the building, maintaining the equipment. The layouts have become better over the years. And rightfully so. I mean, because we're working more with dairies that have hired on more of their nutrient management people to take care of their manure systems, to manage the manure application side of it, to also manage the husbandry of the land, not only the cows, but like just taking care of our land, taking care of where the nutrients need to be, hauled to for the potential growing crops, all those things. So you have those people that are hired to come in and actually manage that whole aspect. And they might have people that they're hiring also from the maintenance standpoint. So we want these systems to evolve and grow with the expectations and make it easy for dairymen and their crews to come in and maintain these equipment, and or a dealer, whoever they're working with, but make it easy to pull the equipment, maintain the equipment. So that way the system continues to function well and it doesn't go the other way. I know we talk a lot about that, like door placement, overhead door placement, right. Man door placement. Where we need to put a place where you can, even wash off equipment or hoses, hose reels, all those drainage. I know I'm a little bit of pet peeve and a pain and a little bit of a pain in the butt when it comes to drains and slopes of concrete. I get a little over the top, probably more so than the engineers like. But I think that all those things play a part in making these rooms. I know we're not designing a house, but making these rooms like efficient, easy to come through, maintain the equipment, and they also stay clean and dry too.
Yeah, I think one of the first systems I was on, designed around the early 2000s, it was more or less a sand separator in the middle of a one-car garage. And so you kind of had to suck your gut in to walk around the machine. It was low, very cramped, very, a lot of odor in that building, just not a good setup, but it worked. There was no problem with it at the time. We didn't know any better. And that's what the customer wanted to use. Fast forward to today, and some of these projects, they're more akin to like a refinery design. We've got very detailed drawings, all kinds of checklists and details that way. And like you said, we go through it and really address the door placement, hoses, utility sinks so you can wash up, control rooms. We make sure that's addressed and taken care of. We don't just plunk a switch in the corner of the building somewhere. We've come a long way in that regard, and there is a lot to it. Maybe it's overthought some of it, but I don't think so. I think with the scope of the projects and what we're doing, we have to look at that stuff up front.
We do.
From a functional standpoint and on also safety, we do what we can to design in as much safety features as we can. Farms are dangerous places, and we don't want the Manure building to be one. So.
Yeah, bring up a really good point on safety and just the confined spaces. Even control panels today. I mean, we used to put the control panel right there on the wall beside the sand separator where the Manure was coming in. So we've learned a lot over the years, and some of those, and it's amazing how long some of those panels lasted. I don't know why. I guess maybe the door to the outside just hung open all the time. So it always got a fresh air exchange. But yeah, I think that the overall design, we obviously it adds cost into it, but I think today we're also looking at that whole value that these systems bring to the dairy and the ROI on the sand recovery part of it, and having a well-managed system and maintained well. You have to have it laid out well. I think too, it goes hand in hand. So that's for sure. We didn't really talk at all about the Manure dryer side of it and what we do there, but conveyance wise, I don't think really much is too different with those types of systems. I mean, really without the sand on the Manure dryers, if you have or Manure bedding, you don't have the sand to contend with. So the conveyance becomes a little bit less forgiving as far as the wear and things like that. We're not really dealing with the high wear of the sand. We're just really concerned with moving the Manure. So same thing there holds true. It could be a flume. It could be gravity. It could be just pushing it to an auger and moving it across the barn. It could be vac tanking it. We see a lot of vac tanking actually with Manure solids as well. I just wanted to see if there was anything here we wanted to add about dryers to this conversation, because that's also a bedding that we're producing to go back under the cow. I think the layouts become a little bit easier because we're not so worried about the abrasiveness of the sand part of it. Would you agree to that? I mean, yep.
Yeah, and that's touched about dryers. We offer solids bedding dryers, and we also offer sand dryers. Yep. As I started out here, I started talking, sand's kind of the gold standard for bedding. We've always shied away. A lot of folks have used solids, and I think if it's managed well, solids can work well too, but you just have to rebed constantly. Where the dryer comes into play is we not only dry out, solids are an organic matter, so kind of can promote bacteria growth and things. So we don't really want to use that for bedding. But if it's managed well and changed frequently, it can happen. And then where the dryers come into play is we get a dryer product in the first place, which is good, but also through the dryer, we get the pathogen kill. And that's the big key. We can put dry solids into a stall that don't already have bacteria growing on them. Obviously, when they get in the stall and they get wet again, there's that chance. But again, as long as it's managed well, it's a good option.
Yep.
And I like the dryers. I think they're a pretty simple thing. I didn't touch too much with sand separation. I mentioned dilution water for we use recycled water for dilution. Where we get that recycled water is we run through a solid separator. We've traditionally used rotary solid separators within our line because they are more forgiving of sand rather than like screw presses and things that are a little closer tolerances, and they perform well. So if we're feeding a digester, and then in the sand systems, we usually take those solids and basically just mix them back together with the effluent to storage or to a digester or whatnot going downstream. So coming into the dryer, maybe we skip the whole sand separation process on the front side if we're not bedding on sand, but the solid separation process still kind of remains the same. And in that case, since we don't have the abrasiveness of sand, we can use screw presses. We can use other solid separation, slope screens, whatnot. But yeah, as you say, the conveyance is simple. You get the initial solid separation. You take those pressed solids off a screw press, roll press, slope screen, convey them into the dryer, and then dry them, and you've got your dry product being stacked on the backside. And any liquid is just processed further and discharged to storage.
Yeah. And most of the projects that we've worked on and worked with the dairy producers and or the dealer on, the dairies were already on Manure. There are a handful of projects here that we've worked through, and I wish we could have maybe honed in a little bit more on the whole transition side of it a little more, going from sand to dried manure solids and adding a digester. And, oh, by the way, adding a digester in between. So that's a whole, that's a whole conversion. Those are intense. They definitely success out there and they are being done, but there's a lot there to learn on the management side of it, especially with the cow and the bedding and that whole part of it, and getting those solids back under the cow. When, how much, do we till them? Do we don't? Do we, or should we be bedding every day? Should we be bedding every other day? How much should we be putting in? What solids, moisture content is best during this time of the year versus the summer, winter versus summer or spring. The humidity probably plays a little bit of a role in it too. So lots of things to learn. The one thing that I will say about the dryer that with the Manure is that it gives these dairies an opportunity to go in with something very consistent day in and day out. If these dryers are set and you have a temperature set, whatever your screw presses are producing, it's going in and it's removing that moisture. So you have a pretty consistent product, and you're making up for the fact that the screw presses could be one day working extremely well and the next day not working so great because something changed, or maybe maintenance needs to be done, or the Manure is just not as thin as it was a day ago. So for some reason it's not coming out the same, or it's a higher moisture content. So there's variables there, even coming off of a screw press that we've seen. And I think that dryer helps even out those inconsistencies. So it gives the dairy producer and the dairy cow a more consistent product, day in and day out. So the dairies that, most of the time we're going in and working with on a dryer, they already have a press in place. They're bedding on Manure solids, maybe post digestion or green. So a lot of that infrastructure is already there. It is pretty straightforward. It does seem very simplistic. I'm sure it's not all simple, but for the most part, it's pretty straightforward. The product coming out is the Manure, pressed Manure. There's not trying to make adjustments to get the Manure solids or the corn kernels out of the sand that's coming out of a sand separator. So when we look at it, I think is for looking at sand for so long and trying to perfect that and make that better. There's a little bit more management there and more fine tuning than there is really with the pressed Manure solids. But looking at the Manure side of it and the pressed Manure side of it, I'm sure there's a lot of upkeep with screw presses. If you want to try to keep that product the same all the time, there's maintenance that goes along with that. I think we've seen inconsistencies with using green Manure, not post digestion, and pressing and drying, where it could be thicker, thinner. Just even going through the screw presses, there's inconsistency, and therefore going even through the dryer, there's some inconsistencies that hopefully the dryer is making up for. But that I think there are definitely challenges with both sides with going sand or solids. But I think the layout side of it and what we've been able to do so far, very little on brand new, out of the gate. Hey, I'm building this, 8,000 cow dairy, and I'm intending to bed these cows with dried, pressed, digested manure solids. I know that's a mouthful, but dried, pressed manure solids post digestion. There's very few, and I believe there's going to be more that are going to go that route and say, look, this is what I want to do. Our model is manure solids, and we put digesters in, and now we want to press these solids, and we're going to bed with them. And how can we enhance our comfort, our milk quality, keep our somatic cell in a certain range? This is our goal. So they want to have a consistent bedding and then at the best they can produce. So we look at the dryer as a tool to do that. I think the layouts will continue to evolve and get better as we get more experience with that. But for now, most of the dryers that have gone in have been retrofits. They've been put in existing buildings or manure solid buildings and maybe expanded, modified a little bit. So we don't really have that evolution yet of going from what we've seen over the past 20 some years with sand, because drying is relatively new to us. And we've been doing it for the past 5-6 years, but we still have a lot to learn there as far as layout, process, and then that whole management piece for the dairyman and the cow. Just to summarize here, we talked a lot about sand and layouts. We kind of digressed into the layout side of it. Same thing with the dryers. But the bottom line is that when we're looking at the entire manure stream, and what we can do on the sand side of it, or post digestion and reusing the solids for bedding, when those solids leave a sand separation building, right now it just seems like the option is we go to storages or digester, and then post digester we go back out to storages, and then that manure is then land applied for organic nutrient uptake, or putting that back on the land so we can incorporate it and put it where the crops are going to be grown that need those nutrients. And then the same holds true, like even if there is a digester and the dairy is bedding on manure solids, a portion of those manure solids are going to be pulled out and recovered to be dried to go back in as bedding. And that's just going to be a constant cycle. But then there's also going to be manure that's going to go to a storage. And at that point, the same thing, land application. What we have seen here lately, and it's been, nutrient recovery and partitioning nutrients and pulling out all the phosphorus or taking out the ammonia or making tea water or potable water. Those types of systems exist. They're out there. We've seen them over the course of the years. Some things have sustained, some things have not. But the bottom line is there, once you have sand removed from that manure stream, it's usually the sand. The other one's a lot more easier to just do whatever you want if you're on manure bedding. But sand, once you have sand-free effluent, whether it's post-digestion or just even post a sand separation system, then there's options to start looking at putting some of this manure stream through, if you don't want to go to storage and land apply, to partition nutrients, to separate out more nutrients, and potentially get those nutrients into a different form. So then they could be exported off the dairy, sold, or you could truck them to farms that you own further away and land apply that product. So it just gives you a more manageable product. So we're not hauling all that nutrient with the liquid portion out to the field, because that's costly when we look at that. And you don't want to be hauling a lot of water just to get more nutrients out to the field. If we can consolidate that and we can put more of those nutrients into a smaller volume, it just makes it so much more efficient for the land applicator, for the dairyman, everybody. And
even just if you're going to pump like dragline or something like that, it opens up options for that. You don't have to worry about
dragline.
It's already been processed, debris removed. It's a good fit. So.
Yep. And it just depends on where you are across the United States. I mean, there's a lot of dairies that will also want to have storages that are just really full of like a water, low nutrient low density of nutrients in that water, because they're gonna pivot, they're gonna irrigate. Because their territory depends on that to get that crop off, is to irrigate that crop because of just low rainfall. So everybody's different. Everyone's model's different across the board. I mean, we probably see a lot more of like the mixed manure solids today, and then trying to like Mark said, inject them, put that organic matter back on the ground. But we do have dairymen today that are looking and utilizing different technologies to take more of the phosphorus out, and then try to get that more into a dry product to deal with it a little bit easier and manage it. And then we have the nitrogen, the part of it too, that they're trying to remove.
Bottom line, regardless of what we do to it, separating sand, drying solids out of it, whatever, there's still a lot of value in the fertilizer that's left. And we can still use that as we've done for a long time now. So we talked a little bit about dilution water for sand separation. And I just want to be clear, we don't use fresh water for that. We do use a little bit of fresh water in certain points of the system just to kind of fine tune and fine rinse. But the recycled water that we use for dilution comes from a solid separation process. We make a rotary drum. We like those because they're more forgiving of sand, but they also do a good job of what we need to do. And so the effluent it's a little confusing, we're looping things back around, but the effluent from the sand separation goes into a series of process tanks. And at that point, we run it through the solid separation. So what we do is we basically break the manure apart. And so the solid separator, we have two products. We have a thickened solids product and we have a liquid product. That liquid product goes into a collection tank, and then that's what we bring back for recycled water. And the thickened solids go into another tank. And at the end of the day, most systems, that the extra recycled water that we've generated overflows into the mixed solids tank. So we do nothing more than break the manure apart, use what we need out of the recycled water, and then we put it all back together. So the manure in and the manure out within our building or within our layout is still the same net result. It's just what we do with it in the middle.
Thank you for listening to Groundwork, our McClanahan podcast. Be sure to subscribe on your listening app for the latest updates and new episodes to come. Thank you.